Hello. What's up guys? Today I am going to talk about how to design a reinforced concrete short column. Before we get started, please subscribe and hit the like button. The problem is to design a tied column cross-section that can support a factored axial load Pu equals 450 kips. A factored moment Mu equals 120 kip-feet. And a shear Vu equals 14 kips. The column is in a braced frame and has an unsupported length of 10 feet 6 inches. So, how to solve this problem? First step, select the material properties, trial size, and trial reinforcement ratio. For the material properties, select a yield strength of non-pre-stressed reinforcement Fy equals 60 ksi. And compressive strength of concrete F'C equals 4 ksi. The most economical range, for the ratio of the total reinforcement area to cross-sectional area of the column, is from 1 to 2%. Thus, we will assume that ρg is equal to 0.015 for the first trial value. So, from equation 1119a, the trial gross area of the rectangular section should be greater than or equal to Pu over 0.40 times F'C plus Fy times ρg. Solving this equation, we get that the gross area should be greater than or equal 230 square inches. However, because moments act on this column, equation 1119a will underestimate the column size. Thus, choose a 16 inches square column. You should note that column dimensions are normally increased in 2 inches increments. Now, to determine the preferable bar arrangement, compute the ratio E over H. E equal Mu over Pu equal 120 kip-feet over 450 kips. Thus, E equal to 3.20 inches. This implies that the ratio E over H is equal to 0.2. For E over H in this range, figure 1123 indicates that a column with bars in 2 faces will be most efficient. Then check for slenderness. Slenderness can be neglected if K times Lu over R is less than 34 plus 12 times M1 over M2. Because this is a braced frame, assume K is equal to 1. And M1 over M2 equal minus 0.5. So, K times Lu over R is equal to 1 times 126 inches over 0.3 times 16 inches equal to 26.3. And 34 plus 12 times M1 over M2 is equal to 28. Because 26.3 is less than 28, slenderness can be neglected. Second step, compute gamma. The interaction diagrams in Appendix A are each drawn for a particular value of the ratio gamma. Gamma is the ratio of the distance between the centers of the outside layers of bars to the overall depth of the column. To estimate gamma, assume that the centroid of the longitudinal bars is located 2.5 inches from the edge of the column. Gamma equal to 16 minus 2 times 2.5 over 16. Thus, gamma approximately equal to 0.69. Third step, use interaction diagrams to determine ρg. The interaction diagrams are entered with Pu over gross area equal to 1.76 ksi. And Mu over gross area times H equal to 0.352 ksi. Because the interaction diagrams are given for gamma equal to 0.6 and gamma equal to 0.75, it will be necessary to interpolate. Also, because the diagrams only can be read with limited accuracy, it is recommended to express gamma with only two significant figures. From figure A6a, interaction diagram for gamma equal to 0.6. Rho g is equal to 0.017. From figure A6b, for gamma equals 0.75. Rho g is equal to 0.014. So, use linear interpolation to compute the value for gamma equal to 0.69. Rho g equal to 0.017 minus 0.003 times 0.09 over 0.15 equal to 0.015. Step number 4, select the reinforcement. Area of steel equal to Rho g times gross area equal to 0.015 times 16 times 16 equal 3.84 square inches. Possible combinations from table A12 are: for number 9 bars, with area of steel equal 4 square inches, 2 in each face, or 6 number 8 bars, with area of steel equal 4.74 square inches, 3 in each face. So, try a 16-inch square column with 6 number 8 bars. Step number 5, select the ties. From ACI code section 25.7.2.2. Number 3 ties are the smallest allowed. According to ACI code section 25.7.2.1. The required spacing is the smallest of the following quantities. 16 times the longitudinal bar diameter equals 16 times 8 over 8 equals 16 inches. 48 times the tie diameter equals 48 times 3 over 8 equals 18 inches. Least dimension of column equals 16 inches. Now we should compute VC. From ACI code section 22.5.6.1. VC equals 2 times 1 plus nu over 2000 times gross area, times lambda, times radical f prime c times bw, times d, equal 51.3 kips. Since the given Vu equal to 14 kips is less than 0.5 times phi times Vc, which is equal to 19.3 kips. Therefore, ACI code section 25.7.2 governs. So, use number 3 ties at 16 inches. Note that ACI code section 25.7.2.3 requires that all corner bars and other bars at a clear spacing of more than 6 inches from a corner should be enclosed by the corner of tie. In this case, the clear spacing is approximately 4.5 inches. So, no extra cross tie is required. Summary of the design. Use a 16 inches times 16 inches tied column with 6 number 8 bars. Fy equals 60,000 psi and F prime C equals 4,000 psi. Use number 3 closed ties at 16 inches on centers. Thanks for watching. Before you go, please subscribe and hit the like button to help me grow this channel.